Hello and welcome to Algorithm Integrity Matters. Insights for financial services leaders who want to enhance fairness and accuracy in their use of data, algorithms, and AI. I'm your host, Yusuf Mullah. This article was published in October 2024 and it's titled A Balanced Focus on New and Established Algorithms. So the background to this is that there are lots of discussions around generative AI going on. And even when we speak about normal AI or algorithms generally, the thinking and discussion and use cases that come up are often in the context of generative AI, so LLMs and other chatbots and things. But the reality is that there's a lot more that exists, older workflows, older uses of machine learning, etc., that really do, at the moment anyway, power more of what we do within financial services in terms of just basic processes, but also things like credit scoring, premium pricing, claims detection, etc. The intent here is to redirect our focus to not just the new, but also establish algorithms that really do play a big part in what we do. So here we go. Even in discussions among AI governance professionals, there seems to be a silent gen before AI. With rapid progress, or rather prominence, of generative AI capabilities, these have taken center stage. Large language models, LLMs, ChatGPT and others, and broader generative AI, so things that generate videos and images, are dominating discussions. They're capturing attention with their impressive capabilities, and rightly so. However, amidst this excitement, we must not lose sight of the established algorithms and data-enabled workflows that have been driving our core business decisions for years. These range from simple rules-based systems to complex machine learning models, each playing a crucial role in our operations. In this article, we'll examine why we need to keep an eye on established algorithmic systems and how. The spectrum of algorithmic complexity. So in financial services, we encounter a wide range of algorithmic systems. And there's a table in the article that represents a basic outline of the complexity spectrum. In practice, the order of these items that we're going to discuss may vary. Many existing systems will use several algorithms from different categories together. So for example, fraud detection systems may combine algorithms from number 2 we're going to speak about and number 4 to create a broader system, which is then more complex than either 2 or 4 individually. Let's just call out the table from 1 to 6. The first type is simple rules-based algorithm or workflow. In banking, we have things like automatic transaction categorization. So for example, classifying purchases as groceries on credit cards and other things, or entertainment based on merchant codes. In insurance, we may have basic policy eligibility checks. So for example, those that decline coverage for provisional license holders for high-performance vehicles. The second type of algorithm or algorithmic system we have is advanced rules-based. In banking, this might be multi-factor authentication systems that use a combination of rules to verify identity, so checking location and device. In insurance, it could be claims triage systems that route claims to appropriate departments based on multiple criteria like claim type or amount. The third type is statistical models. So in banking, a credit scoring model, perhaps. In insurance, maybe a pricing model. And sometimes this goes with number 4, which are machine learning models. Things like in banking, algorithms that detect fraudulent transactions in real time, or in insurance, models that help identify potentially fraudulent claims. So statistical and machine learning are close together. Sometimes they are machine learning, sometimes they are simpler statistical. There's not always a distinction between the two, but they can be. Then we move on. Number 5 is deep learning and neural networks. So in banking, we might have models that predict future cash flow patterns. In insurance, we may have models that help assess property damage from things like satellite imagery. And then at the top end of the complexity spectrum, we have generative AI. And I'm sure there are more in between and more above this, or there will ultimately be more above this. But for purposes of this discussion, we've put this as the last item. So in banking, we might have large language models that power conversational AI for things like personalized service. In insurance, we may have large language models that summarize product disclosure statements to make them easier for customers to read. As we moved along the spectrum, we saw increasingly complex algorithms that can handle more sophisticated tasks. With increasing sophistication, there are new opportunities and challenges, but more sophisticated does not mean more important. A potentially overlooked challenge. It's easy to get caught up in the Gen AI hype. While the new technologies grab headlines, a critical issue often goes unaddressed, and that's our established systems still require significant work. These established systems have often not been subject to the same level of scrutiny and governance that we now expect. So, for instance, a long-standing credit scoring model might be accurate in predicting defaults, but lack fairness in its treatment of certain customer groups. The expectations around fairness are changing. Or a simple system to calculate third-party commissions might have undetected inaccuracies. Maybe not at a macro level, but with the individual commissions to individual brokers for individual loans. Then we have external threats, so bad actors finding new ways to exploit vulnerabilities. Security vulnerabilities, that is. These all pose serious reputational risks regardless of their complexity. Failures in core systems, whether in terms of fairness, accuracy, or security, can severely damage trust in our institutions. Given these challenges, how can we ensure integrity in both new and established systems? Addressing the challenge. Before we dive into specifics, it's important to recognize that focusing on generative AI gives an incomplete, distorted picture. The use cases, inputs, processes, outputs, and risks of established systems are often very different from those of newer AI technologies. So it's useful to keep these use cases at the forefront when determining overall expectations, when identifying specific risks, and designing policies. And what we mean here is that if we're thinking about a simple machine learning model, let's not focus the risks on generative AI. Because generative AI is at the forefront, we can't be thinking about those use cases when evaluating our expectations and risks and policies for simpler, if you like, algorithms. So with that in mind, here are a few steps that we can take to address the challenge. 4 in total. So the first is holistic. So ensure that algorithm integrity efforts cover all systems, not just the latest AI technologies. I mean, that's what we've been talking about in this article all along. The second is modernize. So update older systems to meet current expectations. The third is cross-functional perspectives. Involve diverse perspectives to improve fairness, and this is becoming more and more important. And the last item here, and the last item in this list, but obviously it's not a complete list, is threat modeling. So regularly assessing how bad actors might exploit new and established algorithms. The most important of those is definitely making sure that what we do is holistic. So we cover all systems, not just the latest AI. Going forward, maintaining a balance between old and new. As we navigate the exciting world of new AI technologies, we must not neglect the critical work needed on our established systems, including the simplest rule-based algorithms. It's our responsibility to ensure that all our algorithms meet the highest standards of integrity. This balanced approach isn't just good practice. It's essential for maintaining trust, mitigating risks, and staying competitive. That's the end of the article. Thanks for listening.